If you have ever been told to diversify, someone handed you the conclusion of a document you have never read. I want to show you the room where it almost died. Chicago, the middle of the 1950s. A graduate student is defending his doctoral dissertation, and he is not worried. By his own account, he landed at Midway Airport thinking, I know this field cold. Not even Milton Friedman will give me a hard time. 5 minutes in, Friedman said, Harry, I read your dissertation. And then he said, the thing that has followed this work for 70 years. It is not economics. In the next half hour, I will show you what was actually in that paper, why the most famous sentence about it is one he probably never said, and what it honestly can and cannot do for the money you have today. Because the version of this story you have heard is a triumph. The real one is more useful than that, and it is more honest about what it does not know. Start with the world this paper landed in, because that is the part everybody skips. Before 1952, serious investment analysis meant one thing, and it meant it everywhere. You examined a security. One security, on its own terms, in isolation from everything else you happen to own. You read the accounts. You valued the business. You formed a judgment about whether the price in front of you was lower than the thing was worth. That is a real discipline, and it is not what is being criticized here. It answers a genuine question. Is this one thing cheap? But notice what that discipline never asks. It never asks what happens when you own this one thing alongside the other things already sitting in your account. Every question is about the item. No question is about the collection. There was advice about that. There has always been advice about that. Do not put all your eggs in one basket, which is a proverb. It is a good proverb, and it has been handed down for centuries because it points at something real. It is also completely uncheckable, and that is the problem this whole episode is about. How many baskets? Which baskets? Is 2 baskets twice as safe as 1? Does it matter if both baskets are on the same truck? Nobody could answer any of those questions because nobody had written down what the words in the proverb actually meant. Advice you cannot check is not knowledge. It is folklore that happens to be pointing in the right direction. And there was a second problem underneath the first one, which is stranger and more important. If the only thing that matters about an investment is how much you expect it to return, then the logic has a conclusion nobody wants. Find the single security with the highest expected return. Put everything into it. Diversification would be irrational. Every practical investor alive knew that conclusion was wrong. Not one of them could say why it was wrong in a way you could write down, hand to somebody else, and have them arrive at the same answer. That is the difference between a hunch and a tool. That gap between what everyone knew and what anyone could calculate is where the story happens. Harry Markowitz was born in Chicago on the 24th of August, 1927. His parents ran a small grocery. He went to the University of Chicago and stayed there, which turned out to matter. A bachelor's degree in 1947, a master's in 1950. The place was, at that moment, the center of gravity for economists who wanted to argue with mathematics. His subject was economics, and specifically the mathematical end of it. He worked around the Cowles Commission, which was where economists went to argue with equations rather than with paragraphs. He needed a dissertation topic. And here the story turns on something so small that it embarrasses everyone who tells it. In 1949, he was sitting outside the office of his advisor, an economist named Jacob Marshak, waiting. Also waiting was a stockbroker. They talked, the way people waiting outside an office talk, to fill the time. Nobody has ever recorded the man's name, which is its own small tragedy. And the broker suggested, by Markowitz's own account, that he apply mathematical and statistical methods to the stock market. I want to be careful here because this anecdote gets embroidered. He did not say apply linear programming. He said apply maths to markets. Markowitz took the idea to Marshak, and Marshak did not laugh. That is the entire mechanism of the origin story. A conversation in a corridor with a stranger and a supervisor who said yes instead of no. Almost everything downstream depends on those two ordinary moments. So he went and read what existed on the theory of stock prices, and what he found was a hole. The theory he read described what an investment was expected to return. It did not describe uncertainty at all. Not badly, not incorrectly, it simply was not in there. The models described what you expected to happen and were silent on the possibility that it might not, which, if you have ever held an investment, you will recognize as an odd thing to leave out. And once you notice a missing variable, you cannot stop noticing it. He was 22 years old, and he had found the thing the field had left out. Not a mistake in the existing work, a missing column. Those are rarer, and they are worth a great deal more. What he did next took about 2 years and fits in 14 pages. Portfolio Selection appeared in the Journal of Finance in March 1952, Volume 7, Issue 1, pages 77 to 91. He was 24. He had not yet finished his doctorate, and the argument starts by refusing the thing everyone else was doing. Here is the move. Describe an investment with 2 numbers instead of 1. The first number is the return you expect. Everyone already had that one, and every valuation method in existence was a way of arriving at it more carefully than the next person. The second number is how much that return jumps around. The variance, how wrong your expectation tends to be. That is it. That is the whole first step, and it sounds trivial written down. Risk stops being a mood you have about an investment and becomes a measurement you can put on the same page as the return. And the instant risk is a number, you can do arithmetic to it. That is the part that changed the profession. Now the second move, which is the one people miss, and it is the one that actually matters. Take 2 investments. Each one, on its own, jumps around by some measurable amount. Now put them together in one portfolio and ask the obvious follow-up question. How much does the portfolio jump around? And the answer is not the average of the 2. It is almost never the average of the 2, because it depends on whether they jump at the same time. If they always move together, you have gained nothing at all. You own one thing wearing 2 hats, and the second hat cost you a transaction fee. If they sometimes move in opposite directions, one is up on the days the other is down, and the combination is steadier than either piece. Not steadier on average, steadier in fact, with the same expected return. That is the free lunch everyone talks about, and I want to stop on the word, because there is a problem with it. The most quoted sentence about this idea is, diversification is the only free lunch in finance. It is attributed to Markowitz constantly. It does not appear in the 1952 paper. The honest sources say only that he is reported to have said it. I am telling you that because this channel does not hand you a quotation it cannot stand behind, even a nice one. What is genuinely in the paper is better than the slogan anyway. The slogan tells you diversification is free, which is the kind of thing you nod at and forget. The paper tells you exactly how much of it you are getting, from which pairs, and what determines the amount. And the mechanism has a name, which sounds forbidding and is not. Covariance. It means, do these 2 things tend to move together? And how strongly? That is all it means. It is a number for togetherness. And once you can put a number on togetherness, you can put a number on the benefit of owning 2 things instead of 1, which is what the proverb never managed in several hundred years of being repeated. Strongly positive means they rise and fall as a pair. Around 0 means each one does its own thing regardless of the other. Negative means one tends to be up on the days the other is down, which is the rarest of the 3 and the most valuable. And here is what Markowitz proved. The risk of a portfolio is not built from the riskiness of its pieces alone. It is built from the togetherness between them, which means you can hold volatile things and end up with a portfolio that is calmer than any one of them. And it means the reverse, which is the warning half of the theory and the half that gets forgotten. You can own 20 different things and be almost completely undiversified if all 20 move together. 20 holdings is not diversification. 20 holdings that respond to genuinely different forces is diversification. Those two sentences look almost identical, and they describe completely different portfolios. Count how often you have heard someone describe a portfolio by the number of positions in it, as though the count were the point. That is the pre-1952 habit, alive and well, 70 years after somebody proved it measures the wrong thing. Now put those two numbers together and ask the question that produces the picture everybody has seen. Given a set of investments, and given what we think their returns, their variances, and their togetherness are, which combinations are the good ones? And Markowitz's answer is precise. A combination is good if you cannot get more expected return without also taking more risk. If you can find another mix that gives you the same return with less bouncing, the one you are holding is not merely unlucky. It is provably wrong. Not a matter of taste, not a matter of view. The word is dominated, and it is a hard word on purpose. There is a better version of your own portfolio available to you at the same price, and no argument about market outlook can make that untrue. Draw every non-dominated combination, and you get a curve. That curve is the efficient frontier. Picture it with risk running left to right and expected return running bottom to top. Every possible mix of your investments is a dot somewhere in that space. Most of the dots are bad, and bad here has an exact meaning rather than a rhetorical one. Bad means there is another dot sitting above it or to the left of it. The frontier is the upper edge. For each level of risk, the best return available. For each level of return, the least risk required. And what the picture does that the equations do not is make the trade-off visible. You cannot ask for more return without moving to the right. That is not pessimism, and it is not a warning. It is the shape of the thing itself, and no amount of skill or conviction changes the geometry. Which is why the theory refuses to tell you which point to pick. It never did. It was never supposed to. It says, here is the menu of honest auctions. Where you sit on it depends on how much bouncing you can live with. And that is a question about you, not about the maths. That is a strange thing for a Nobel-winning theory to say about itself. And it is the most grown-up sentence in the whole framework. It hands you the menu, and then it refuses to order for you. There is one more consequence, and it is the practical one. A security that looks terrible on its own can improve the whole portfolio if it moves against the things you already hold. Its job is not to be good. Its job is to be different. And an investment industry organized entirely around persuading you that things are good has very little vocabulary for describing things that are merely different. Read that against how investments are sold to you, and you will notice something. Almost every pitch is about the thing on its own. Is it a good company? Is it a good sector? Is it a good story? Told well by somebody confident. All single security questions, and every one of them answerable without knowing a single thing about you. Markowitz's question is the other one, and it is a question nobody can answer for you without knowing what you already own. He wrote it down in 1952, and then he had to defend it. Mid-1950s, back at Chicago, the oral defense. I said at the start, he was not worried. And there was a reason. This was his own department, and he had done the work. The paper was not a draft or a proposal. It was already published in the Journal of Finance, sitting in libraries. Five minutes in, Milton Friedman said he had read the dissertation and that he could not award a doctorate in economics for it. Because it was not economics. Now, here is where nearly every retelling of this story goes wrong, and I am not going to do it. The satisfying version is that a famous economist failed to recognize genius sitting in front of him. That version is false. It makes both men smaller than they were, and it teaches you nothing you can use. Friedman was not arguing that how securities are priced does not matter to economics. Both of them later agreed on what the objection actually was. The work was about a procedure, algorithms for building portfolios. It was not a theory about how the economy behaves. And in the mid-50s, that distinction was not pedantry. It was real. There was not yet a field where this work belonged because finance as an academic discipline barely existed. He had written a founding document for a subject that had not been invented, which means Friedman was not wrong about the boundary. He was standing exactly on the line while somebody moved it. Markowitz got the doctorate. The story is told as a joke by everyone involved, including him. But hold on to that objection, because 35 years later, in Stockholm, he answers it directly, and the answer is one of the best lines any laureate has given. Before we get there, we have to sit through the part of the story that nobody dramatizes. The waiting. Because the paper came out in 1952, and then, for something close to a decade, essentially nothing happened. No adoption, no wave. The most consequential paper in the field, sitting there, being cited politely. And the reason is not that the profession was stupid. The reason is arithmetic. Think about what the method actually demands. For every investment you are considering, you need an expected return and a variance. Fine. That is 2 numbers each. But you also need the togetherness between every single pair of them. And pairs multiply in a way that gets out of hand almost immediately, far faster than most people's intuition expects. 10 investments is manageable. 100 investments needs thousands of pairwise estimates. Tie! In 1952, computing that was not merely expensive. For most institutions, it was not available at any price because the machines that could have done it were not in their buildings and in a good many cases were not yet built. So the idea sat there, correct and unusable, which is a very common condition for correct ideas and one this program keeps running into. Being right early is, from the outside, indistinguishable from being ignored. Markowitz went to the Rand Corporation in Santa Monica in 1952 and worked there through 1960 and again from 61 to 63. Rand is where the computing was. It is also where he did work on simulation and on programming languages that has nothing to do with portfolios and would be a whole episode on its own. And it is where he met a young researcher named William Sharp. Sharp took the problem that was blocking everything, the impossible number of pairwise estimates, and asked whether they could be approximated. What if, instead of measuring how every investment moves against every other investment, one pair at a time, you measured only how each one moves with the market as a whole? One relationship each, rather than a relationship with everybody. That single simplification turned an intractable calculation into one you could run. It is also where the idea of a single market sensitivity number comes from, the one you have seen called beta. And notice the shape of what just happened, because it is the shape of this entire program. The toolmaker is rarely one person. Markowitz defined the problem correctly, which is the hard half. Somebody else made it computable, which is the half that decides whether anybody ever uses it. The tool is the pair of them, and the field usually only remembers one. Through the 60s and 70s, the framework spread from a paper into the machinery of how institutions actually allocated money. Slowly, unevenly, without a single dramatic moment anywhere in it, which is exactly why nobody makes a film about it, and why most of the people using the vocabulary daily could not tell you where it came from. And by the late 80s, an entire industry was running on the vocabulary of a 14-page paper from 1952. Risk. Adjusted, correlation, asset allocation, efficient, all of it downstream of the same document. Which brings us to Stockholm. 1990, the Sveriges Riksbank Prize in Economic Sciences in memory of Alfred Nobel. Shared 3 ways: Harry Markowitz, Merton Miller, and William Sharp, the man who had found the simplification that made Markowitz's method possible to actually run. The prize put the pair of them back together. 38 years after publication. And in his lecture, Markowitz went back to the defense. He did not settle a score. He conceded. He said that at the time he defended his dissertation, portfolio theory was not part of economics. And then he said, but now it is. I want you to notice what kind of sentence that is, because it is rarer than the prize. He agreed with the objection. He simply pointed out that the boundary had moved in the intervening decades and that his own work was a large part of what moved it. That is not a rebuttal. It is something rather better than a rebuttal. Friedman was describing the map as it was. Markowitz was drawing a new one. Both true, both at once. He kept working for another 3 decades on simulation, on optimization, on the practical mess of implementing his own theory. He died in San Diego on the 22nd of June, 2023 at 95. So that is the triumph. Now here is the part that matters more, and the part that most videos about this leave out entirely. Because a tool you do not understand the limits of is not a tool. It is a superstition with equations attached. Limit 1, and it is the big one. The method does not know anything. It takes expected returns, variances, and correlations as inputs. It does not produce a single one of them. You do, or somebody selling you something does, and the machine has no way of telling those two apart. Feed it confident nonsense, and it will hand you back a beautifully optimized portfolio built on confident nonsense. And it will look precise while it does it, which is worse than looking uncertain because precision is persuasive in a way that honest hedging never is. A number with a decimal point on it reads as a fact. Limit 2. Those inputs are usually estimated from history, and the optimizer is unusually sensitive to small errors in them. Nudge one expected return slightly, and the recommended mix can change a great deal. Practitioners have spent decades building constraints to stop exactly that. Limit 3, and this is the one that has been learned repeatedly through expensive experience rather than from a textbook, which is usually a sign that the lesson does not stick. Correlations are not constants. Things that moved independently for years can start moving together at exactly the moment you needed them not to. The diversification is measured in calm weather and it is tested in bad weather, and those are not the same measurement. Nothing in the mathematics warned you about that. The mathematics assumes the relationship you fed it still holds. Limit 4. Variance treats a surprise upward and a surprise downward as the same event. No human being alive experiences those as the same event. Markowitz knew that perfectly well and worked on alternatives that penalize only the downside, which tells you he was never as attached to his own first formulation as his critics were. Now, do those limits mean the theory is wrong? No. And the distinction is the entire point of this program. The insight is not fragile. Risk is measurable. Combination matters more than selection. Togetherness is the variable. Every one of those survives all 4 limits intact. What is fragile is the output, the precise recommended weights that come out of the far end when you feed guesses into the front of it. The idea and the arithmetic have very different levels of trustworthiness, and they arrive in the same box. So the correct way to hold this tool is trust the idea, distrust the decimal places, which honestly is how you should hold most tools that come out of this program. And that gives us something you can actually do, which is where we always finish. 4 things you can take from a 1952 paper and use on whatever you are holding right now. None of them requires any math. 1. Stop counting holdings. Start asking what they respond to. If everything you own would react the same way to the same piece of news, then you own one position wearing several different names, and the number of lines on your statement is telling you a comforting lie. It costs nothing to believe, and a great deal to act on. The question is not how many. The question is, what would have to happen for all of these to fall at once, and how likely is that? 2. Judge a new holding by what it adds, not by what it is. The honest question when something is put in front of you is not, is this good? It is, what does this do to the thing I already have? Something mediocre on its own that moves differently from everything else you hold can be worth more to you than something excellent that moves exactly in step with the rest of it. That is the most counterintuitive sentence in the paper, and it is also the most useful one. 3. Pick your point on the trade-off deliberately and write it down before you need it. The theory will not choose for you. Nobody can, but the choice exists whether or not you make it consciously, and the default is made by whoever sold you the last thing you bought. Decide in advance how much bouncing you can watch without acting. That is your position on the frontier, and it is a fact about your temperament, not your spreadsheet. 4. Treat any precise-looking optimal allocation as an opinion in costume. When a number arrives at one decimal place, ask what was fed in to produce it. If the inputs were estimates, and they always are, then the output has inherited every bit of that uncertainty and is now hiding it behind a very clean-looking figure. The precision is real. The accuracy is a separate question, and only one of those two is being displayed to you. That is the whole toolkit. Combination over selection, difference over quality, your trade-off chosen on purpose, and a permanent suspicion of tidy numbers. And it comes from 14 pages written by somebody who, at the time, could not get his own department to agree it counted as economics. Which is worth remembering the next time an idea gets waved away for being the wrong shape rather than for being wrong. Those are different objections, and only one of them is about whether the thing is true. He did not win that argument in the room. He won it by being right for 38 years until the room changed. Next episode, the toolmakers go somewhere very different and much more contested. Gerald Apple, and an indicator built out of nothing but two moving averages subtracted from each other. MACD. Markowitz built a tool that tells you what you cannot know. The next one is a tool that millions of people believe tells them what happens next. Whether it does is a genuinely open question, and we are going to treat it as one. If this was useful, the follow button is what tells the channel to keep making the long version instead of the short one. I am Maja. Thank you for the half hour. One more thing, because there is a question this always produces, and it deserves a straight answer. People ask whether modern portfolio theory has been disproved, and the answer depends on which claim you mean. If you mean the specific mean variance optimizer as a machine for generating portfolio weights from historical estimates, that has been criticized heavily by practitioners for decades, and much of the criticism has landed. If you mean the underlying claim, that risk can be measured, that combinations behave differently from their parts, and that correlation rather than count is the variable that matters, then no, not disproved. That is now simply how the subject is taught to everybody who studies it. Those two things get argued about as though they were one thing, and almost every heated disagreement about this topic is really two people talking about different claims. It is a useful habit, generally, when something is being attacked, ask which layer is under attack, the insight or the implementation. Usually, it is the implementation. Usually, the insight is fine. And the second question people ask is whether he was rich. I do not have a sourced answer to that, so I am not going to invent one. What is on the record is that he spent the rest of his working life on the unglamorous end of his own idea, making it run. Fixing what broke when real people used it, which is the toolmaker's job description, and it is why this program exists. Nobody names a fund after the person who defined the problem. They name it after whatever the problem let them build. The last thing to say is about the shape of the whole story, and it is the reason I picked it for this series. A 22-year-old had a conversation in a corridor with a stranger whose name nobody wrote down. A supervisor said, "That sounds interesting. Go and look at it." 2 years later, there were 14 pages. The pages were correct and completely unusable for a decade because the arithmetic was too expensive to do. Somebody else found the simplification that made it runnable. The two of them shared the prize 38 years later. And in between, an entire profession quietly changed the questions it asked itself, without ever announcing that it had done so, which is a large part of why almost nobody can name the person responsible. That is what a tool does when it works. It stops being visible. It becomes the thing everybody assumes. You were told to diversify by somebody who had never read the paper, who heard it from somebody else who had not read it either. Now you have read it. 14 pages, 2 numbers per investment, and 1 about togetherness. Expected return. variance, covariance. That is the whole vocabulary. And the sentence underneath all three, what a thing does on its own, is the least interesting fact about it. That is true of investments. Friedman would probably say it is also true of ideas, and that a paper on its own is not a field. He would have been right about that too, right up until he was not. Sources for everything in this episode are in the description, including the ones I disagreed with. Next week, 2 moving averages subtracted and one of the most argued about lines in finance. Gerald Appel and Mac D. Whether it predicts anything is the question, and I am not going to pretend the answer is obvious. See you then.